Hi everyone. You're watching the Space Channel. Black holes are among the most well-known astronomical objects. Thanks to their extraordinary properties, they frequently appear in science fiction. But writers and filmmakers often portray them inaccurately, either because they don't know their real properties or to create a dramatic effect. That has led to numerous myths and misconceptions about black holes that have persisted in people's minds. We've analyzed the questions our viewers have asked on our Ukrainian channel over many years and put together a list of the most common myths to debunk them. Myth 1. Black holes are giant vacuum cleaners that suck in everything around them. In reality, black holes follow the same laws of orbital mechanics as stars and planets. They attract objects solely through gravity, which depends on an object's mass and its distance. Planets, comets, and asteroids can orbit black holes on stable paths, just like they do around stars. For example, if our sun suddenly turned into a black hole of the same mass, Earth's orbit wouldn't change. The planet wouldn't get sucked in. Myth 2. When a star collapses into a black hole, its gravity increases. That's not exactly true. You can explain why in two ways: within general relativity and within Newtonian gravity. The GR explanation is more accurate but also more complex, so we'll use the Newtonian approach. It's more intuitive and leads to the same conclusions. Example: the sun's radius is about 700,000 kilometers. Its mass is spread across a huge volume. On the screen, you can see a schematic representation of the sun's gravitational pull on Earth. However, if we take an object that's located very close to the sun, or even inside it will be pulled in different directions by different parts of the sun. As a result, these gravitational forces partially cancel each other out, reducing the net force. If the sun collapsed into a black hole, its radius would shrink to under 3 kilometers. The region with a 700,000 kilometer radius that the sun used to occupy would now be empty, so any body inside that region would feel gravity pulling essentially in just one direction, making the gravitational pull on it much stronger. But for planets orbiting far away, almost nothing would change. Even before the collapse, they felt the sun's gravity as if it came from an almost point-like mass. So there's a grain of truth in the myth. The gravitational pull does increase, but only for objects that end up very close to where the star collapsed. Myth 3. A black hole is a portal to another world or another part of the universe. This myth is common in science fiction. Its truth or falsehood hasn't been confirmed by observations, but all indirect evidence suggests black holes themselves are not portals. The myth arose because Einstein's gravitational field equations have multiple solutions. One describes a black hole, and another describes an object with opposite properties, a so-called white hole. A white hole only ejects matter and can't swallow anything. In theory, it could be the exit from a black hole. However, astronomers haven't observed any object with the properties of a white hole, so their very existence is highly doubtful. There's a hypothesis that white holes could exist in other universes, but even then, no human could survive a journey through a singularity. That said, black holes are considered a potential mechanism for creating wormholes, hypothetical tunnels that, under certain conditions, might connect different points in spacetime. Myth 4. Black holes swallow everything that comes near them. In reality, no black hole absorbs 100% of the matter that falls toward it. Some of it is always thrown back into space, and the smaller the black hole, the larger the fraction that gets ejected. What happens when an object encounters a black hole depends on the distance. Usually, objects don't fall straight in. They start orbiting and form an accretion disk, hot gas torn apart by tidal forces. The rate at which a black hole can swallow matter is limited by its own size, so a significant portion of that gas is simply flung back into space. If a black hole gets close to a star, it will begin pulling material off the star, eventually upsetting the balance between gravity and internal pressure and triggering an explosion. Even then, the black hole only consumes part of the star's matter. Only supermassive black holes, with hundreds of millions to billions of solar masses, can come close to devouring a star almost entirely. These are far from all the myths about black holes. I'll cover more in upcoming parts. To make sure you don't miss them, subscribe to the channel and hit the bell. That's all for now. Thanks for watching, and see you next time.